Hello and welcome back to the Enrichment series. We're going to get right into episode 5, talking about composite and inverse functions. In this particular episode, I'm not going to be really teaching how to find composite. Or inverse. I'm kind of just assuming that you have a general understanding of it. But the application should help you sort of understand why we do these things and um, give a little bit of context. So in this part, we're going to talk about composite functions and just see what they're all about, how they apply to the real world. And just as a general refresher, if you have two functions, f of t and g of t, and you want to compose them, you would write them either as f of g of t with the little circle down there, or you would just go ahead and put g of t within f of t and write it as the second one here. I think the second one is a lot easier to see, but you're also going to see it written the first way. So prepare yourself for that. And then inverse is for another time. Let's go ahead and ask ourselves a very existential question here. Why do we compose functions? And the way I see it, I think it's really just about relating variables and doing that in a way where you can make certain calculations easier. So if we know that A relates to B, and we know that C relates to A, then we know there must be some sort of connection between C and B. And sometimes that connection is just really important for a certain scenario, and you want to have a function that shows that direct relationship. On the right here is a quick example. If we had A equals 2B plus 5, and I actually wrote this as A of B because I think that way it's easier to see B is your input. So that's the first one there. And then we also have C of A equals A cubed. So if I want to find that relationship between C and B, so first of all, there's this. Between A and B, there's that relationship. And then we also have one between C and A. We know that C and B must relate. And the way we can do that is through composition. So we can basically plug in the function for A into the C function. So we write that as this third line right here. C of A of B. And I know that looks like a lot, but basically what we did is we replaced this little guy right here with this big old function. And now we get to include B, which is what we want. So when we see it written this way, basically everywhere that we see A in the function for C, we're just going to plug in the equation for A. So in this case, A only appears once, and the equation for A is 2B plus 5. So we're going to plug that in, and we're going to cube it. And that's what composition is all about. Another thing that you need to be able to do in the pre-cal class is also recognize when you have a composition, and typically that will happen when you have parentheses. So just as a quick example here, if we had y equals 1 over x plus 3, and the pre-cal people ask you to write that as f of g of x, or just identify what f of x is and what g of x is. Basically, whatever's in parentheses is going to be like your inside function. So in this case, we might put x plus 3 in parentheses. So that's going to be our g of x. That's x plus 3. And then so whatever we're doing to that function is going to be your outside. So f of x, we're just doing 1 over. So 1 over. And then anywhere where you put g of x, you're going to put x now. So it's kind of the opposite of what we were doing before. And then you can check yourself. So if I had to put g of x into this function, you would have an x plus 3 right there instead of an x, so we did it right. And that is another skill to have. Okay, I'm going to move my face so we can see the problem. We're going to do 2 different examples here and then do more complicated stuff for the next video. But for the first example, let's say a cylindrical container initially has 500 meters cubed of water. It is being filled at a constant rate of 100 meters cubed per second, and then the radius of the container is 50 meters. So we want to write a formula for the volume of the water after t seconds. Essentially asking you to relate V and T. Trying to get the pink. No, that's too skinny. Okay, that's good. Okay. So we want to relate volume and time, V of T. Well, they gave us an initial volume, 500. It's increasing 100 per second. So we can write that as 100T, because after every second, it's going up by 100. And then add 500 to that because that was the initial value. Boom. All right, part B. Write the formula for the height of the water in terms of V. And some people get confused by the phrase in terms of, but it really just is trying to tell you what is your X value or what is your input. So anytime you see in terms of blank, the blank is going to be your input. So really this is just saying write an H of V formula. And then so on the other side of that equal sign, you're just going to have a bunch of V's, or just one, I don't know. But we need to be able to relate height and volume. And the way that we can do that is with the formula for volume. We're going to have to rearrange it a little bit. But let's create a little side part here. So we know that volume, in its most simple terms, it's the area of the base times the height. So I'll write that as BH. They told us it was a cylinder, so the base is going to be a circle, pi r squared. I don't know why I said it like that. And then we're going to multiply that by the height, which we don't know. And they told us it was in terms of V, so we don't want that r right there. They told us that the radius was 50, so we would plug in 50 for r. Which I will do right now, I guess. So pi times 50 squared, which is a number, times h. Okay, so we just related volume and height, but we don't want volume to be the dependent variable. We want it to be in terms of volume. So basically what we're going to do here, volume is going to be on the top. And then in the bottom of the fraction, we are going to have pi times 50 squared. Because I just took this right here, volume equaled pi times 50 squared times h. So then I just divided both sides by pi times 50 squared. That way I could get h by itself. Okay, and that is our formula. But we are not done yet. We want to find the composition H of V of T, and we also want to explain what it means. So I want to change back to pink. We saw that another way to write this would just be H of V of T. Wow. And then essentially what that means is we're going to go to our H equation, and everywhere we see V, we're going to plug in V of T. So I shouldn't have wrote that under there because now I'm confused. H of V of T, write it again over here. So V just appears once on the top of that fraction, and we're going to substitute the equation we found in part A to do 100T. That looks like plus sign. That made it worse. Sure. And then that's going to be plus 500. And keeping everything else the same, it's just going to be pi times 50 squared. I really want to fix this t. Better. Okay, so you can see what just happened. We had a relationship between volume and time. So let me do this in a certain color. So volume, time. We had a relationship between height and volume, which means there was a relationship between height and time. And we just created an equation for it. But the second part here, we need to explain the meaning. And essentially what this is, what we just found is a function that models the height of the water over time. And that's what you would write if you had to write it out. So if you're more visual, height of water over time. I have the watermark getting in the way. Yeah, height of water over time. And that took longer than I thought it would, so I'm going to do the second question in the next video.